Okay, so this is question 3 from paper 6B, and we've got a lovely graph. I can already see it's got progesterone on it. Gotta love a hormone. So, pregnancy testing involves detecting changes in the concentration of the hormones progesterone or human chorionic gonadotrophin in blood or urine. Graph shows how plasma concentration of these hormones changes during pregnancy. So we've got ovulation here, then we've obviously got formation of the embryo, and when it hatches out and implants it's churning out HCG. Could that be HCG going up and up till the end of pregnancy? So I'm thinking not. HCG would go up and then decrease once it's kind of done its job of maintaining the corpus luteum. Still a lot higher than usual. So I'm thinking that this will be progesterone here. It's also, if you look, there's nothing, no HCG before that fetus is formed, whereas the progesterone we have got. So okay, so I'm going to say that that one's HCG, that one's progesterone. We've got time from the last period in weeks, so this is the whole pregnancy. Birth over here somewhere, conception sort of after ovulation. And we've got HCG and progesterone, arbitrary units. So progesterone going from 0 to 300 and HCG going from 0 to 120. Identify each of the two hormones shown in the graph. Explain which will be the best indication of pregnancy in the early stages. Okay, so hormone A is progesterone, and hormone B is HCG. And we can use that because we've been told it's called HCG, so that's okay. So that's got to be worth a mark. So why have we chosen that one? Which one would choose the best indication of pregnancy in the early stages? HCG. Why would that be? So HCG would be the best indicator. As levels rise rapidly, and progesterone levels are about the same before and after ovulation. And I might have put, HCG doesn't appear until the event, or isn't present around ovulation. Okay, so describe. So what are we thinking? So I'm thinking we should know what our hormones are, AO1, and maybe thinking about the pregnancy, AO2 or 3 there. So I'm thinking that's a sort of split thing. Maybe AO3 for the conclusion. Part 2, describe. So this is just going to be AO1 stuff, isn't it? The role of these hormones in the early stages of pregnancy. So what does hormone A do? What did we say hormone A was? Progesterone. Progesterone, what do we know about that? Progesterone maintains the uterine lining. Need to make a bit of a point about what that's for. Ready for implantation. And hormone B, HCG, HCG maintains the corpus luteum. So that it keeps on producing progesterone. And I'm just going to add into that maintaining the level. And here we've got another graph. Oh, another graph. Not. So what have we got? It's a bar chart. Percentage of women in sample. So those are all percentages. We've got past ovulation 21 days after, so this is longer. This is a shorter time. Post ovulation, 5 days post. So we've gone ovulation, and we've measured it there, and we've measured it 21 days there. Okay, so on our timeline we've got ovulation there, we've got 5 days, and we've got sort of doing it 21 days. Okay, pregnancy tests in kits were developed in the early 1980s. I'd love to know what they did before then. So I was thinking African clawed toads, you could look that up. The ancient Egyptians used to tip the urine onto wheat, and apparently it makes it germinate. Don't know whether that's true. Early 1980s, to detect one of these hormones in urine, I'm not telling you which one. The diagram shows the results of pregnancy testing in a sample of 1,200 women, 5 and 21 days following ovulation. All of the women conceived at the time of testing, so they were all pregnant. So we've got some negative results, but they were all pregnant. We've got strong positive, standard positive, faint positive, very faint positive. Okay. But they're all pregnant. I don't know where these negatives are coming. 85% of them were showing a negative test. That's slightly worrying, isn't it? Anyway, explain why the negative results, explains a given reason why the negative results were treated as false negatives. I'm even going to, no, you shouldn't do this in English. Because, explain word, all of the women were pregnant. And I'm just going to have a quick look at the graph, because 21 days, I suppose you've had your peak of HCG, probably an ideal time to do it from this graph would be about day 10. You wouldn't probably know you were pregnant then. 10 days after ovulation, you probably really wouldn't. Anyway. Calculate the number of women in the study. So we had 1,200 altogether who were given a positive result at 5 days. Right, so we're only looking at positives 5 days. So we've got 5 days, this is this one, that's a negative result. So we've got positive, 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 positive. So we need to add all those numbers up together. And remember that they're a percentage. So 0.8 plus 1 plus, that's a bit inconvenient, isn't it? 3 plus 10.2 plus 10.2. So they're the percentage of women. So that's 100. And then we need to multiply them by the number we had at the beginning, the number of ladies. Okay. just do the maths thing and put that in brackets. It just looks a bit tidier. Of course, the other way to do it would have been to go, right, 85% of them didn't show it, so you could have done 85%, 85 over 100, showed a negative, worked that out, and then multiplied it, taking it off then 100%. So I've done it the more complicated way. It's just the way my brain works, I'm afraid. Plus 3 plus 10.2, that's 15% of 1200 divided by 100 to make it a percent, times 180. That's not very many, is it? I suppose in the early 80s probably not that bothered.